Students, now I am going to teach magnetic field along the axis of the current carrying circular coil. To discuss this question, we consider the circular coil. Carrying a current A. To calculate the magnetic field produced along the axis of the current carrying circular coil, we consider the center of the coil is O and it has a radius is capital R, and we take the 2 points on the coil. This is C, this is D. At a point C and D, we take the elemental length, that is dl. We consider the length of the coil, that is dl. It is a vector quantity, so we cannot, that is a dl vector. To calculate the magnetic field produced along the axis of the current carrying circular coil, we consider the point P at a distance Z from the axis of the circular coil. Z from the axis of the circular coil. The current carrying element ideal vector is perpendicular and with the point P, it has the distance is R. Here we take, that is R vector. Same as from the point D, it has the length R vector. Here the R vector be the vector joining the current element ideal vector and the point P. So the R vector be the vector joining the current element and the point P. So when the current passing through the current carrying coil at the point P, due to the current element at a point D, there is experience a magnetic field. That magnetic field is directed along S. Same as due to the current element at a point C, there is experience a magnetic field. It is directed along the direction of R. So according to Bayes-Savart law, the magnetic field at a point B, at a point P, due to the current element ideal vector at C, due to the current element ideal at a point C, there is experience a magnetic field is calculated by using the Bayes-Savart law. So we can write dB vector is equal to, you know the value, that is mu naught divided by 4 pi ideal vector divided by the distance R square into R cap. So here we are going to take the magnitude of dp vector. So it is a vector quantity. From this we calculate the magnitude. What is the magnitude? That is dB is equal to mu naught divided by 4 pi I dl vector means dl sin theta divided by r square. So next step, it can be written as dB is equal to mu naught divided by 4 pi I dl divided by r square. Sin theta means that is the angle between the current element and the point P. According to this diagram, the angle between the current element ideal and the point P is equal to 90 degree. Here it has the angle. Okay, so this is a circular coil. In this circular coil, we are taking the point P here. So here it has the angle. The line it has the angle is 90 degree. Okay, so sin 90 degree. So the value is dP is equal to mu naught divided by 4 pi IDL divided by r square. Here theta is the angle between ideal vector and r vector. It has the values 90 degree. So we can write dB is equal to mu naught divided by 4 pi ideal divided by r square. So here you can take the direction of the dP. Already I explained to you the magnetic field due to the ideal at a point C, it is directed along the r direction. Here the current element ideal at a point D, at a point B there is experience a magnetic field is directed along the S direction. So here, so to calculate the magnitude of the magnetic field, we take the angle of the axis of the circular coil and the current element. It is making the angle is phi. So if it is resolved by the horizontal components means here the S is resolved by the dP cos phi. Same as here, R is resolved by the dP cos phi. Suppose if it is acting vertical means here it is resolved by the dP sin phi. Here it is also dP sin phi. Okay students, so see the diagram. Okay, it is making the angle is phi. So horizontal components means it is resolved by the dP cos phi. Vertical components means it is resolved by dP sin phi. So for the horizontal components, here we take it is directed R and S vector. It is resolved by the horizontal components means dP cos phi, it has the same magnitude and it is acting opposite direction. So it will cancel each other. So it is resolved by the sine components only. It is resolved by the sine components only. So we can write the magnetic field dP vector due to each current element is resolved by two components. dP cos phi along y direction horizontal components and dP sin phi along perpendicular, that is Z direction vertical component. Okay friends, so we know that the horizontal components cancel out. So vertical component alone contribute to the net magnetic field. So we can write the B vector is equal to integral of dp vector. Field is resolved by the sign components. We can write a B vector is equal to integral of dp sin pi k cap. K means it is acting along the z direction, so we can write dp sin pi k cap. So we know the values of the dp. It is substituted in this equation means B vector is equal to integral of what is the dp, mu naught divided by 4 pi. This value is mu naught divided by 4 pi ideal divided by r square sin pi k cap. From the equation, now we are going to take the values for the sin pi. To take the sin pi, we consider the triangle OCP. From the triangle OCP, we are going to calculate the values of the sin pi. What is sin pi? This is a pi. So opposite side is, that is OC. OC means that is equal to R. That is the radius of the circular coil, R. So next is hypotenuse. What is the hypotenuse? Hypotenuse is R. Okay. So to calculate the values of R, we are using this Pythagoras theorem. From the Pythagoras theorem, what is the values of the R square? R square is equal to, that is OC square. OC square means that is R square plus OP square. OP square means that is Z square. So what is the values of the R? R is equal to R square plus Z square power 1 divided by 2. Okay students. So that value substituted in this equation means we can write what is the values of the sin pi. Sin pi is equal to R divided by R square plus Z square power 1 divided by 2. So we know the values of the R and R square, and we know the values of the sin pi. So to calculate this magnetic field for the circular coil, we need to integrate these values. So substitute the lower limit and upper limit. For the circular coil, the lower limit is starting from 0 and end to the 2 pi r. Okay students, it is a circular coil, so we take the lower limit is 0, upper limit is 2 pi r. Okay, and mu naught divided by 4 pi I dl divided by, what is the values of the r square? R square means r square plus z square, in the sin pi means r divided by r square plus z square power 1 divided by 2 k cap. Okay students, so now it can be written as B vector is equal to, we are taking this constant values on outside, that is mu naught divided by 4 pi mu naught I divided by 4 pi integral of 0 to 2 pi r dl divided by r square plus z square power 3 divided by 2 into r k cap. Okay students, r square plus z square into r square plus z square power 1 divided by 2, it can be written as r square plus z square power 3 divided by 2 r k cap. So it is, so students, we can write B vector is equal to mu naught I divided by 4 pi. So we take constant values on outside, r divided by r square plus z square power 3 divided by 2 integral of 0 to 2 pi r dl k cap. So in next step it can be written as B vector is equal to mu naught I divided by 4 pi r divided by r square plus z square power 3 divided by 2 into first integral of dl. Integral of dl means that is L, lower limit 0, upper limit 2 pi r k cap. Integrate this values. Integral of dl is equal to L. So b vector is equal to mu naught I divided by 4 pi r divided by r square z square power 3 divided by 2. First substitute the upper limit 2 pi r minus lower limit 0 k cap. So it can be written as b vector is equal to mu naught divided by 4 pi r into 2 pi r, 0 cancelled. Okay, r into 2 pi r means that is 2 pi r square. 2 pi r square divided by r square plus z square over 3 divided by 2 k cap. So 2 pi 4 pi, so it is cancelled means what is the remaining value is b vector is equal to mu naught I divided by 2 r square divided by r square plus z square power 3 divided by 2 k cap. Okay, this is the final answer, students. So now we need to calculate the magnetic field at the center of the circular coil. At the center of the circular coil means in this, at a point O, we need to calculate the magnetic field at a center of the circular coil means we need to calculate the magnetic field at a point O. At a point O means what is the values of the Z? Z is equal to 0. So Z is equal to 0. It is substituted in this equation means what is the P vector? P vector is equal to mu naught I divided by 2 r square divided by r square, Z square 0, so r square power 3 divided by 2 k cap. So r square power 3 divided by 2 means it will be changed to r cube. So b vector is equal to mu naught I divided by 2 r square divided by r cube, so 1 divided by r. So what is the answer? That is mu naught I divided by 2r. Mu naught I divided by 2r. That is the magnetic field at center of the circular coil. If the coil having n turns, the number of turns in a coil is n means we can write the magnetic field B vector is equal to mu naught capital N I divided by 2 and 1 divided by R. Okay, if n is the number of turns in the coil, we can write B vector is equal to mu naught N I divided by 2R.